Hello, I'm Giancarlo Tosi, Product Manager for Dadanco, and I'm going to be covering Revit MEP and using our selection software in order to update the models inside of BIM, updating the family objects. Where this all starts is from our selection software. Um, this is where you would set up all of your zones. So you would do all your loads for all your perimeter zones, and each of these zones would have units that would have unit tags inside of these. So this is important to note because these unit tags are going to be linked into the Revit MEP. So when I update these in the selection software, it'll automatically update all the parameters inside of those Revit families. So when you first do your selections, um, I'm not going to cover the selection software. You can view all of our tutorials here, which is linked off of our selection software, which will bring you to our website. And this is the Dadanco training channel. And on this channel, you can also see typical, sizing a typical office for active chill beams, creating the BIM objects data and using the ACBs. So that's all off in our YouTube training channel, and that can be found also off of our website, dadanco.com. And you can also download all the BIM objects right from our website. So if you click on that BIM object or select BIM from the literature library, it'll have all of our Revit files contained on that site. Also to note, you can also download the selection software program right from the site as well. So to get back to this, once you set up all of your zones and they are matching up with all of your loads, so you have your sensible load for the space, where your latent loads are, you would do your selections. Selecting your unit model, size, primary airflow, and this will give you all of your performance metrics. Sensible cooling, total cooling capacity, and all of these can also be changed. So if I need to bump up my flow rates, I can change that, and that will update my capacities. From there, once I have all my loads and zones set up, I'll click this Create BIM Files button. What this is doing is creating a text file that's going to be linked to our Revit families. So you can download those Revit families from our website, RFA files, and save them in the same directory that you store this text file. So the selection software will create that text file in the same directory that it's in, and then you want to download the BIM files or the RFA files and put them in the same directory. Once that's set up, when you go into Revit, and if I load these families, again, you have to locate where you save them, and they need to be in the same location as those text files. So the way that would look like, I just think it's important to show. In this folder, I have this text file, which is the selection software is producing this text file, and that text file needs to be in the same directory as the RFA files. So that's very important. So your RFA files need to be the same directory as your text files. Once I load them in Revit, so I'll do load the 20s. And you can load these all at the same time, or you can load them individually. This will contain all the parameters. My primary air, supply air, static pressure, as well as your inlet sizes and all those performance characteristics. From there, let me go into my design view here. Let's just pick a zone over here in this office space, maybe a perimeter zone. Once I load these families, I can go in here and start adding these families into the zone. these are ACB 50s and they are one-way blow. So you can see from this that these have little arrows indicating which side of the airflow is blowing from. And then this also has instant parameters. These are family parameters that have all the performance data in here. Your inlet size, if you have any connections, your plumbing, water, mechanical, airflow, 161 CFM supply air, and that's all being driven from the selection software. On the instance characteristics, I can also set this up to have, this right now has the primary air inlet in the front. I can put that on to the right, and then I might put my discharge on the rear, and then my coil connections will be on the left. So once I apply that, you'll see everything jumps around to match that. And then from there, I can draw my ductwork off of that and connect it to my primary air. And then off of here, I can also connect my my pipework. Connect the plumbing, supply and return. The other thing that the models will do, which is kind of nice, is that if we are in the ceiling grid, this is where are we over here? As you can see, there's some lighting fixtures and stuff in here. So, and we want to align this to match up with our ceiling grid. So if you look at this, this will snap to the center of this grid here. If I come in real tight, you can see that's right in the center of that ceiling grid tile. Now, once I have that all set up, I might notice that I need more airflow or a bigger unit to be supplied in the space. So let me just see what unit this is. This is ACB 10, and it's an ACB 50. That's the tag, and this is the model is an ACB 50. So I'm going to go back to my selection software and find that ACB 10 that I already updated here. And I might want that to be a 4-foot unit, and I'm going to bump that up to 100 CFM. Might need a little bit more primary air to do that. So I'm gonna make this a 4-foot unit now and put in 100 CFM, and of course all the supply air rates and performance. I can also pump up my chilled water as well if I need to. Then from there I'm going to create my BIM files. And then if I go back to my Revit file, here's my ACB 10, and you have to reload these families. My documents, where did I put this? When it was an ACB 50, I think it was ACB 10 we said, right? So now you see this is a now going to be a 4-foot unit. See, right now it's a 2-foot unit, so when I update this, this magically expands. Well, because I already connected to the duct, I'm going to delete those elements that I've already connected those ductwork to. Now I can see that I have a 4-foot unit in the same space, and it's snapped into the grid the same way. Also, as you can see, the one that we changed the sizes on, I mean the direction of the primary air and the plumbing, the instance characteristics don't change, just the family. So all the families will change, but you can see this one is blowing in the opposite direction than this one. I don't know if they're going to let me move this, because yeah, okay. Cancel that. Once it's connected to the ductwork, it's not going to let me to move this one around. So as far as workflow is concerned, I would put the units in the space, do all my sizes and loadings, and then connect up my ductwork afterwards. So as you can see, this unit expanded. The other thing we can look at is our for these units. Oh my, a lot of units in here. Well, let me go to one of the systems here that I have connected. Oop. So if I go into one of these systems here, I can look at my system browser for that unit. Let me expand this a little bit so we can see what's going on here. So these units have 100 CFM. So I'm going to need for this system, I'm going to need 600 CFM for these units that are there. That might be too much. So this is an ACB3. So I can go back to my selection software on the ACB3. And let's cut that in half. Probably doesn't need to be an inch of static pressure. So we're going to drop that down to 0.5 static pressure and 50 CFM. And save that file. Now when I load that family, I'm just going to load that ACB3, just that one unit. Now you can see it dropped down to 300 CFM and 50 CFM. The other thing we can do with this system is I can drop in a spec the system. So I can see the flow in each of these units. So it's a 50 CFM and 0.53 static. And then as I move up the ductwork, you can see that the CFM is adding up, as well as the direction of flow. And if I go into my plan here, I can also see the the colors here. I have quite a bit of these in here, so that relates to 100 CFM for the orange, and then the purple is 50 CFM. This is also true with the plumbing or chilled water. So I can see in this system, I think I only have the supply set up on this one. So we have 2 GPM for each of these units in here. Let me look at these family parameters. So it's 1 GPM. I can also go back and change this. We can also analyze this as well. One GPM, and then as we go along, we can see the so what unit is that? ACB4. So when I go back into my selection software under that ACB4, I might need to reduce that chilled water. 1.6 might be too much. So I can reduce that to maybe 0.6, and as you can see, all the BTUs or the sensible cooling will change as I adjust this. So I can more closely match my loads as well as my pump requirements. What unit was that again? ACB4, was that it? Yeah, ACB4. And create that BIM file. I'm just saving all of them. It's just faster for me that way. You don't have to save every single file every time, but it's just easier for me to do right now. Now when I come in here, I load my family. What type of unit was that? I think it was a 20. ACB4. Okay. So it automatically updates my system in my browser over here. And if I inspect that system, I can see that I've reduced the flows. And you can see that also on the family parameters. The other thing that makes it a little bit easier is it also will update your schedule. So once you have your schedule set up with all your tagging and fields that you want to include, primary airflow, static pressure, temperatures, this will also automatically update when you update these units inside of here. So all these models are intelligent models. In each of these models, we can change all of the instance properties, which include your offset. So each of these can be at different levels as far as to match up with your ceiling grid. Primary air, we can switch those. Drain connections on or off, as well as you can reset your identity data on each one of these. So if you need tagging for each of these units, you can change that as well. So that's the instance properties. Kind of all the work stuff that we put in here. We can also note if it's an NPT connections, any material and finishes, and then your temperatures, your loads, dimensions, and then all of the identity data for each of these units as well. We also include sound level and all the information that's contained in the selection software. So instead of having to edit each one of these individually, you can very simply look at that zone, look at what the loaded requirement is that. So I might have 6 of these units in this zone to meet that requirement, make those selections, and then very easily update our BIM families and objects inside of that without having to change everything. Again, if you have any questions, you can contact me, and thank you.